Okay, so lecture 2 for Math 113, spring 20, I don't know why I thought it was 2019. I am living in the past, apparently, 2021. Okay, so a little bit of review. If we have a unit circle with an angle t and a corresponding point x comma y, then we have these definitions for sine and cosine. So here's my point x comma y. I can draw a vertical line and a horizontal line. This distance here is x, this distance is y, because y is up there, so this point here is x comma y. Cosine t is x, sine of t is y, tangent of t is y divided by x. Secant is 1 over cosine, cosecant is 1 over sine, cotangent is 1 over tangent. This is a circle of radius 1 that tells me that x squared plus y squared equals 1, and if you turn that into terms of cosine and sine, cosine squared plus sine squared equals 1. So a bit of a review. So reference angles, what is a reference angle? So we have two basic triangles. One is the 45, 90 triangles. So two 45-degree angles and a 90-degree angle. And the sides, as we showed last time, have length 1 over root 2. And then we also have a 30, 60, 90 triangle. Right, that's my right angle, 90 degrees. This is 30 degrees because it's a smaller angle. This is 60 degrees because it's the bigger angle. This side is square root of 3 over 2. This side is 1/2, and that side is 1. Okay, so with those triangles, can we determine sine of 3 pi over 4 and cosine of 3 pi over 4? So here's my unit circle. I need to draw the angle 3 pi over 4. The denominator is 4, so that means I need 1, 2, 3, 4 angles. 1 pi over 2, 2 pi over 4, 1 pi over 4, 2 pi over 4. This one is 3 pi over 4. That's 3 pi over 4. So that means that if I look at this triangle, right? This angle in here is whatever is left over from going the full 180 degrees from the positive x-axis to the negative x-axis. And that, going all the way around here, that's pi radians. So if you go 3 pi over 4, how much do you have to keep going to get to pi? Well, that makes this angle pi over 4. So I'm going to redraw that picture without quite so much stuff in it. Here's my angle 3 pi over 4. This is the point xy, whose coordinates we want to know. And this triangle now, we know that this is pi over 4, or 45 degrees. And so this triangle must be a 45, 45, 90 triangle. And so this is what's called a reference angle. It's the angle back down to the x-axis. So what are these two side lengths? This side length is 1 over root 2. This side length is 1 over root 2 because that's a 45, 45, 90 triangle. So what's x? And here's where we have to be a little bit careful about the difference between length and coordinate. How long is this if you got out a ruler and measured it? Well, you get a positive number because the length of something is a positive number. But as a coordinate, it's to the left of the origin. So that means my x coordinate is minus 1 over root 2. My y coordinate is how far up we go, because we're going up, that's positive. Great, so now we can figure out our Trig functions. Cosine of 3 pi over 4 is x. So it's minus 1 over root 2. Sine of 3 pi over 4 is y. So that's plus 1 over root 2. And tangent of 3 pi over 4 is the ratio of sine divided by cosine. Since it's the same number, but only with a minus sign different, that becomes minus 1. Now, secant of 3 pi over 4 is the reciprocal of cosine. That means just take this thing and flip it, minus square root of 2. Sine if we want to calculate cosecant, that's 1 over sine. It's the reciprocal of sine. So that's also square root of 2. And cotangent is 1 over tangent. It's the reciprocal of tangent. And 1 over minus 1 is just minus 1. So those are other trig functions. So a reference angle means that if you have an angle in a triangle and it's more than 90 degrees like we had here, you can find a triangle like this with an angle that's less than 90 degrees, and you can figure out what the trig values are for that. So what about 5 pi over 3 and cosine 5 pi over 3? Well, same kind of deal. We want to know, first off, where is 5 pi over 3 as an angle? So we're drawing my unit circle. 5 pi over 3, that means I'm going to get 3 angles in the bottom, 1, 2, 3. That's still not enough, then we need 5. So we have 3 angles in the top, and then we need 1, 2, 3 angles in the bottom. So 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. This must be 5 pi over 3. And that's my angle. So here's an angle that's less than 90 degrees that completes my 5 pi over 3. We know 6 pi over 3 is all the way around the circle. 6 pi over 3 is 2 pi. That's all the way around the circle. So if we're going 5 pi over 3, this one must be pi over 3 there. And pi over 3 is equal to 60 degrees. So redrawing this picture a little bit more tidily, we have a unit circle that looks like this. We've got an angle down here. This is the angle 5 pi over 3. To find its trig functions, we need to know the coordinates of this point. But we know that this angle here is 5 pi over 3. That's pi over 3, which is 60 degrees. And so we can draw on this triangle. This angle must be 30 degrees. So we have buried in there a 60, 90, 30 triangle. That has a length of 1/2. This has a length of square root of 3 over 2. This has a length of 1. We're in a unit circle, so it's a length of 1. So what's my x coordinate? Well, we'll go to the right. So we go to the right 1/2 unit. What's my y coordinate? Well, we actually go down square root of 3 over 2, right? Down square root of 3 over 2. So that's minus square root of 3 over 2. Okay, so cosine of 5 pi over 3 is 1/2. Sine of 5 pi over 3 is square root of 3 over 2. Tangent of 5 pi over 3 is sine divided by cosine, so it'll be square root of 3 divided by 1, which is just square root of 3. Secant of 5 pi over 3 is the reciprocal of cosine, so that's 2. Cosecant of 5 pi over 3 is the reciprocal of sine, so that's 2 over square root of 3. And cotangent of 5 pi over 3 is reciprocal of tangent. Think of tangent as a fraction square root of 3 over 1, so its reciprocal is 1 over square root of 3. And sine should have a minus sign on it, and so should tangent, because it's sine equals minus square root of 3 over 2, tangent equals minus square root of 3 over 1. Because this y value is negative, so my cosecant is also negative, and my cotangent is also negative. So these three are reciprocals of these three. So these are the primary ones, cosine, sine, and tangent. So what's the sign of sine, S-I-G-I-N, of plus or minus of trig functions? It depends on what quadrant it is, and stat cats, it is a palindrome. Right? Reads the same way backwards and forwards. And for me, that's one way to remember where in which quadrant my angle is, what the sign of my trig functions are. So cosine is x, sine is y. So in this quadrant, quadrant 2, x is greater than 0 and y is less than 0. So cosine is positive. Ugh, sorry about that. I got that backwards. This one, x is greater than 0, y is greater than or equal to 0, y is less than 0. Cosine is positive here. Because if x is positive and y is negative, cosine is positive, sine is negative. Okay, up here, x is positive, y is positive, so that means all are positive. Down in this quadrant, x is less than 0, y is less than 0. That means cosine is negative and sine is negative, but tangent is sine divided by cosine, so the minus signs cancel out. So tangent is positive. And in this last one, x is less than 0, y is bigger than 0. That means cosine is negative, but sine is positive. So sine is positive. C-A-T-S, cats, stack, backwards. So that's one way to remember it. The book also has, let's see, how does a book do this? Their phrase is a smart trig class. That also helps remember it. I like cats. Okay, it looks like a little tail there. It is. So if cosine of t is negative, what quadrants could t be in? Well, everything is positive here, and cosine is positive here. So if cosine is negative, that means we have to be in this quadrant, the second quadrant, or in the third quadrant. And I don't know why quadrants are always written with Roman numerals. It just are. At least they are when I was growing up. So how are trig functions defined by right angles? So we've defined trig functions in terms of angles in the unit circle, but we can take them out of the unit circle and work with them a little bit. So here's my unit circle. Here's my angle t. There's my x and y coordinates. And that becomes a triangle like this. And this is the cosine, and this is the sine. So we can take the triangle out and just say, well, here's an angle T, here's a side A, here's a side B, here's a side C. This is often called the opposite because it's the side that's opposite from the angle T. This is the adjacent, and this is the hypotenuse. Hypotenuse, HYP. So what is cosine of t? Cosine of t was x, so that's going to be the adjacent over the hypotenuse, right? The x over the radius. So that'll be b over c, or adjacent over hypotenuse. Sine of t is the opposite over the hypotenuse. So that's going to be a over c, or opposite over hypotenuse. And then tangent is sine over cosine, right? Y over x, so that's a over b, or opposite over adjacent. Right, what are the other 6? Well, secant is 1 over cosine, so it's going to be c over b, which is hypotenuse over adjacent. Cosecant is 1 over sine. It's reciprocal of sine. So that's C over A, which is hypotenuse over opposite. And cotangent is the reciprocal of tangent. So that'll be B over A, which is opposite over adjacent. Oh, sorry, adjacent over opposite. So a way to remember that is SOHCAHTOA, sine opposite over hypotenuse. That's the SO. Cosine adjacent over hypotenuse. That's the CA. And the TOA is tangent opposite over adjacent. So that's one way to remember the relationships there. So suppose a right triangle is an angle of 22 degrees and the side opposite the angle has length 4. What's the lengths of the other sides of the triangle? So we can draw on a right triangle, however you want to do it. There's my right triangle. There's my 22 degrees. Opposite here is 4 equals opposite. A, that's my adjacent. And C, that's my hypotenuse. I keep putting that, running my Y and P together. Okay, so there we go. So how can I find these things? Well, we remember that sine of an angle is opposite over hypotenuse. We know the opposite and we know the angle. So in this particular triangle, we have sine of 22 degrees equals 4 divided by hypotenuse, which means that hypotenuse equals 4 over sine of 22 degrees. And so if you calculate that out, you get about 10.678. So that's my hypotenuse. I need to find the adjacent. What's a formula I know that involves the opposite and the adjacent? Well, that's tangent. So for any angle T, tangent is opposite over adjacent. So for this particular triangle, tangent of 22 degrees should be equal to 4 over adjacent. Solving for the adjacent gives me 4 over tangent of 22 degrees, which is about 9.9. So how can you check that? Well, you check with Pythagoras, right? A squared plus B squared should equal C squared. So if I take the opposite and the adjacent is 9.9 squared plus 4 squared. We get about 114.01. If we take my hypotenuse and square it, that's 10.678 squared. We get about 114.02. There's some rounding error here, but close enough, right? So we found the lengths of the other side. So if I know an angle and a length of one side, I can figure out all the other sides. So what's the complementary angle to theta? So let me draw in a picture again. We have 22 degrees here, we have 90 degrees here, and we have some angle up here that are called S. So how many angles are in a right triangle? There's 180 degrees in a triangle, but 90 of them here. So these two have to add up to 90 degrees. So S is 90 minus 22, which is 68 degrees. right? And this is, what were the numbers that we had up here? My adjacent was 9.9. And this was 10.678. So now we know that S here is 68 degrees. So what's the relationship between the trig functions of 22 degrees and the trig functions of the complementary angle 68 degrees? Well, sine of 68 degrees should be opposite of 68 degrees, which is 9.9, over hypotenuse, which is 10.678. But that's the cosine of 22 degrees, because the cosine of 22 degrees is the adjacent to 22 degrees over the hypotenuse. So the adjacent for 22 degrees is the opposite of the 68 degrees. So tangent of 68 degrees is opposite over adjacent. But that's the same thing as cotangent of 22 degrees. And finally, secant of 68 degrees is, well, it's 1 over cosine. So it'll be hypotenuse over adjacent, 10.678 over 4. But that's hypotenuse over opposite of 22 degrees. So that's the cosecant of 22 degrees. And that's why they're named the way they are. Sine of, if you have a right triangle, the sine of one of the degrees is the cosine of the other degrees. The tangent of one, well, the sine of one angle is the cosine of the other angle. The tangent of one angle is the cotangent of the other angle. The secant of one angle is the cosecant of the other angle. The cos stands for complementary functions. These are also called cofunctions, cosine, cotangent, cosecant. So here's a right triangle. Find the other sides and find the angle T. Finding the other sides isn't too bad. If you know two sides in a triangle and you want to find the third, if it's a right triangle, pull out Pythagoras. 5 squared plus 4 squared equals c squared, where this side is c. So 25 plus 14 equals 41, and that's my c squared. That tells me that c equals square root of 41. So c is the square root of 41. So that's not too bad. What's the tangent, though? So tangent of t is opposite over adjacent, so it's 4 over 5. What is the angle? And on your calculator, or however you calculate these things, you should find a button labeled tangent to the -1. Or it might be labeled arctan. And we'll talk a little bit later about what these things mean. But the idea is, if you know the angle, right, use this button to get the, no, if you know the tangent, use this button to get that. So tangent of 4 over 5 is the angle that we want. So my calculator, I will calculate 4 over 5, which is 0.8, and then hit the tangent inverse button. And that tells me that my angle is 38.66 degrees. You should, at this point, find your favorite calculator, or however you calculate things, and make sure that you get that. Make sure that when you do this, that your calculator is on degrees and not radians, because you'll get a weird answer otherwise. Okay, so if cosine of t is -2/5 and t is in the third quadrant, what are the other 6 trig functions? So here, if we think about this in terms of the unit circle again, we know quadrant 1, quadrant 2, quadrant 3 is down here, quadrant 4. So cosine of t is -2/5. So here's my radius 1. It's a bad picture, but that's okay. And this must be my cosine. That's my x-coordinate minus 2/5. And this is the angle T that I'm looking for. And I want to know what is this point. So if cosine T is minus 2/5 and T is the third quadrant, how do we find that out? Well, again, we can use, we don't actually have a nice reference triangle here because it's not 45, 45, 90 or 30, 60, 90, but we can use Pythagoras again. 2/5 squared plus, call that y, equals 1. So that's 4/25 plus y squared equals 1. Y squared equals 1 minus 4/25, which is 21/25. So y equals square root of 21/25. And we want the negative value because my y value goes down. So x is minus 2/5, y is this. Taking the square root of the top and bottom makes it minus 21/5. So what are my trig functions? Sine of t is minus square root of 21/5. Cosine of t is minus 2/5. Tangent of t is sine divided by cosines. The 5s will cancel out, so will the minus signs, and we get square root of 21/2. Right? Remember, in the third quadrant, CATS. Only tangent is positive there, and cotangent. So cosecant of t is the reciprocal of sine, so minus 5/21 inside the square root. Secant of t is the reciprocal of cosine, so that's minus 5/2. And cotangent of t is the reciprocal of tangent, so 2/square root of 21. Great, so what happens if we just have a point in the plane? So an angle is in standard position, and its terminal side goes through this point. So what does that mean? If we draw this in the plane, -7 is over here, 5, so here's a point. The terminal side, standard position, means the positive x-axis is one side of my angle, and that's the terminal side. So this is the angle that we're dealing with, t. And this point is -7, 5. And so we don't know right now what the trig functions are because we're not in a unit circle, but we can draw a triangle. Here's a nice triangle. And what's our triangle that we just drew? It looks like this. We've got a right angle down here. The height is 5. This length is 7. Remember, I'm thinking this just as a distance, not as an x-coordinate, because I want to figure out what the third side is. 7 squared plus 5 squared equals 49 plus 25 equals 74. So the third side is 74. So now I have a nice triangle. I want to know what, I know what those 2 points are. Can I figure out what my trig functions are? And here's my reference angle, would be there. So sine of my mysterious angle t must be opposite over hypotenuse. Now we know the hypotenuse is square root of 74. So that would be 5/square root of 74. Cosine of t is, well, here it has to be negative because it's actually the x-coordinate that we want. And tangent of t is the ratio of sine to cosine, so -5/7. So that's not too bad. Remember, in this quadrant, in the second quadrant, sine is the only thing that's actually positive. C-A-T-S, cats, S is up there. Okay, again, cosecant of t is the reciprocal of sine. secant of t is the reciprocal of cosine, and cotangent of t is the reciprocal of tangent. And there's my 6 functions. One thing we want to know, though, what's the angle? And so I asked my calculator, what's tangent inverse of -5/7? And it tells me, a very annoying number, it tells me -35.54. And that can't be right, right? Because my angle T has got to be a positive angle and it's got to be bigger than 90 degrees, right? And that's a negative angle. But what negative angle is it? Well, suppose I draw a line, just continue this line down this way, and I get the point 7 minus 5. And I think about this triangle here. So that triangle has tangent equal to -5, because it's the y coordinate -5 divided by the x coordinate 7. And so that must be the angle my calculator is talking about. So tangent, remember, can have, if I'm out here, right, you get a tangent is -5/7, but also 180 degrees the other way is also -5/7. So what angle is T? Well, T plus 35.54, that must be equal to 180 degrees, right? This whole angle has to be 180 degrees. And so T must be 44.46 degrees. So be a little bit careful when you're looking at your output from your calculators, because there are many possible angles, and then your calculator will give you one, but you want to make sure you have the picture so you can tell what angle you're actually dealing with. If you know the value of a trig function, you generally don't know the value of the angle. And so one way to think about this is, suppose we're in the unit circle, and you're told that sine of t is 1/√2, and sine of t is y. So there's 2 possible angles that we could have, this one or that one. Then the question is, what are the 2 possibilities for cosine of t? And that would be the x coordinate here, which would be 1/√2, or the x coordinate over here, which is -1/√2. Because we know that this is a 45-49 triangle, because we recognize this as a side of 45, 45, 90 triangle. So cosine t can either be 1/√2 or -1/√2, because this would correspond to t equal to pi/4. That's this angle. And this would correspond to t equals 3 pi/4, which is that angle. Both of these angles have sine of t equal to 1/√2. So if sine of t equals 1/2 and t is the second quadrant, what is cosine of t? So sine of t is 1/2. T is in the second quadrant, so that means we're over here. And so we must be looking for this point here. And this is the angle that we're dealing with. Recognize that that comes from a 30, 60, 90 triangle. Right? One side is 1/2, one side is √3/2, one side is 1. So if sine of t is 1/2, and we're in the second quadrant, then this, my cosine, must be -√3/2. Keep in mind, 1/2 minus √3/2, that comes from a 30, 60, 90 triangle. 1/√2 comes from a 45, 45, 90 triangle. You'll be seeing this over and over again. So finally, what's an application of all this stuff? So in the picture below, someone wants to know how wide the river is. And the river is the blue part here. The person is standing on a bluff. The bluff is 10 feet high. So this distance here is 10 feet. And the tool they're using, that's the red thing, And in medieval times, it'd be called Jacob's staff. That's 5 feet tall. And I'm not going to put in the height there because I don't have enough space. The smaller angle, that's this one here. That's measured to be 12 degrees, and that's what the Jacob's staff does. It allows you to measure how far you are away from the vertical. And the larger angle from here out to here is measured to be 75 degrees. So how wide is the river? Right? And so note that we've got 2 triangles, right? So this person sights from where they are down to one bank and gets a triangle like this. They know that the smaller angle is 12 degrees. And they know the height is actually 15 feet, right? 15 feet because they're standing on a bluff that's 10 feet high, and they've got a Jacob's staff that's 5 feet high, so 15 feet overall. And this is the opposite. And they want to know, and this is the hypotenuse, they want to know how long is this distance. That would give you the distance from here to here. So how long is that distance? Well, what's something that involves a formula that a trig function that involves opposite and adjacent? And that's tangent. Tangent of 12 degrees equals opposite, which we do not know, over adjacent, which is 15. So 15 times tangent of 12 degrees equals my opposite, and I punch that into my calculator, and we get 3.19 feet. So that's how far this is. So if we look at the larger angle, we get a triangle, got the same 15-foot high on the bluff, 75 degrees there, and we still want to know what's the opposite and what's the, we don't actually care about the hypotenuse. So tangent of 75 degrees is opposite over 15. 15 times tangent of 75 degrees equals the opposite. And if you grind that through your calculator, you get 55.98. And that distance is this entire distance. We want this distance, though. That'll be 55.98 minus 3.19, or 52.79 feet is the distance across the river. And this is how people used to measure distances across the river without actually having to go out and hike around and get your feet wet and stuff. Oh, sorry, you don't need to see me here.